Okay, good morning. Welcome to
SummerMath number 13.
Summer Math number 13. We've been working on complementary counting yesterday and today, actually. And I pulled some problems out of my old book, combinatorics book called Jackson and Thoreau, I'm not sure how to say it. And we were working on one this morning that took quite a long time. Okay, and it was, how many four-digit odd integers have distinct digits? And we found that it was 2,240. And how did we find that?
Well, casework. We had to do casework.
We did a lot of casework. We found for the first three digits, we knew the last digit was odd.
Yeah.
And then we had to figure out if the first three digits were all even, if one of them was odd, and that had three cases. If two of them were odd, that had three cases. And then if they were all odd, there was only one case for that. And we added all those cases together and got 2,240. The next question is, how many four-digit even integers have distinct digits? So what's one way to do that?
Well, the same way we did the last problem.
The same way we did the last problem. Now, that took probably 20 minutes, right?
Yeah.
So do you think I would have picked it for a 5-minute video if that
Probably
was the
not.
only way to do it?
Probably not.
There's a very clever way to approach this problem now that we know the answer to this one. Okay, we know there's 2,240 odd integers that have distinct digits. How can we use that to find the number of even integers that have distinct digits?
Well, we just switched the odds and evens around.
Well, but that's going to bring us back to casework.
Yeah, but like from all the work we did this problem, just switch the odds and the evens.
Right. You're absolutely right. We could do all the casework again.
Yeah, but that's no fun.
So that's going to take a long time. So we're looking for a different way, not casework. Okay, we already know there's this many odd integers that have
Well, you
distinct.
could do complementary counting.
Okay, how's complementary counting going to help us here?
Well, these are the ones that are odd. We need to find everything.
Ultra super high five. Like even higher. Yes! If we found all the integers that have all the four-digit integers that have distinct digits, what could we do now?
Then we just subtract 2,240 from it.
We subtract the odds, and what are we left with?
The evens.
The evens.
So
this problem, it turns out, if you know the answer to the first part,
You can
isn't so hard. So how many total four-digit integers are there with distinct digits? Who
Well,
wants to do this one?
me.
Okay.
Is that okay?
The first one is 1,000. The last one is 9999. There's 10,000 numbers.
Wait. I don't think that's right.
Okay, why not?
Well, because it says distinct digits.
Four-digit numbers with
Oh, yeah.
distinct digits. We're looking for distinct digits.
So you can't have the repeats.
Okay. So what's another approach here? And it's 9,000, by the way. So
Yeah.
Not 10,000, but
It's still not right.
still not right. Okay. How are we going to count the four-digit integers that have no repeats?
Well,
Okay.
Well, you could find the repeats.
Well, how many choices do you have for the first digit?
You have 9 choices.
right.
How many do you have for the second digit?
Yeah.
8.
Well, but you can't use 0 for the first digit, so
Oh yeah, 9. 9 again.
yeah.
9. How many here?
Then comes 8,
Then comes 8.
and then comes 7.
Then comes 7. So I have 9 times 9 times 8 times 7. Oh, hand me my phone, please.
So now we can do that on the calculator.
Okay, so that's not the easiest calculation in the world. So since we want to do it quickly, 9 times 8 times 7 is 4536.
Wow. Total.
That's the total four-digit integers
And now,
where they have no repeats.
and now we just have to subtract that.
Subtract 2240. And you should be able to do this in your head. It's 2,300
and then
minus 10
minus 10
plus 6.
plus 6 is
it's 2299 2294.
2296.
2296 plus 6. There we go. That's a pretty cool use of complementary counting. Great idea. Great idea. And then you just have to count the digits. Okay, so you count 9 for the first, 9 for the second, 8, 7, 4, 5, 3, 6. Now I've got 2296. Now isn't it interesting that there's more even 4-digit numbers that have distinct digits than there are odd numbers that have distinct digits?
There's 56 more.
There's 56 more.
Cool.
Maybe
Wonder what
someday
that
we'll
is.
wonder about that. Okay?
Yeah. Yep.
All right. In fact, I just figured it out. That's your homework problem. Figure out why there are more evens than odds. Okay?
All right.
All right. Good job, guys.